Okay. So if we look at the second one. All right, so if the first one is y equals, well, no. The first one is g of x equals 5 times the square root of x minus 10 minus 3. But what do we do to that graph of f of x, which is 5 times the square root of x, to get g of x? What? Good. So this tells me right 10 and down 3 units. Good. All right, let's look at the next one. Now this is a cubed root. Cube root. Okay, so g of x equals negative cubed root of x minus 10, but f of x is the cubed root of x. So, what does this do? Down 10. Down 10 units. But what does this do?
Flipped it over the x-axis.
So, mathematically speaking, we would say reflect over what axis?
X.
Good. All right. So, g of x equals this, and f of x equals this. So, what transformation happened to f of x?
Left 6.
Left 6.
Down 5.
And down 5. Okay, so, whoops. So, all of these are basically in our form where we can see the transformations very easily, aren't they? Well, we got to figure out what to transform first. So let's go back and look at the parent graphs for these. F of x equals the square root of x. Now, where did we see this before? Does anybody remember? We quickly looked at it. Does anybody remember studying this one? And then when we found its inverse, what was the inverse of this? What did we do? We switched the x and y, didn't we? And then we took the square root of both sides, didn't we? Now this gives us plus or minus, but on a lot of them we just looked at part of it. So when we looked at this function, y equals x squared, it gave us this, right? So if we did the inverse, we get this. And remember, the inverse is just a reflection over what line? The y equals x line. So that's not even close to the y equals x line. Let me try again. I know, it's bad. Better? Okay. So it would look like, let's switch colors. We'll do that one in green now. So this one would look like this. Something like that. Okay? Now, do you see how we're not looking at both parts here? We're just looking at the positive. Y, f of x equals the positive square root of x. So when we go to graph it, let's go old school. Old school, we would start with a table. And just about every time on my table, I'd always go -2, -1, 0, 1, 2. Every time. So if I plugged in -2, I go, root, because I'm taking the square root of negative. And that's imaginary, isn't it? So it doesn't really graph for me, does it? That's not helpful. Okay, let's throw in square root of -1. That's just I. Where do I graph it? Not there. Not really helpful. Okay, square root of 0. 0. Square root of 1. Square root of 2. Oh, we don't know it. It's about 1.4, isn't it? Okay, so maybe 2 wasn't the best number to pick. Is there a better number to pick?
4.
4. Okay, the square root of 4 is 2. What's another good number? 9. Square root of 9 is 3. So we're going to graph that. We're going to start with 0, 0. 1, 1. I'll go over 1, 2, 3, 4, up 2. I'm off my graph, but if we had a bigger graph, we could keep going. When I studied these, when we study a whole function unit, and I taught a different class, we called this one the eyebrow. Because it kind of looks like an eyebrow. But obviously this function continues, and thankfully our eyebrows don't. So,
Eyebrows to infinity.
yeah, just wrap right around her head and keep coming back. Yeah. Okay, so this is our parent function, guys. And we could think of these right here as being basically our moves for our parent function. We're going to start here, then we're going to go over 1 up 1, over 4 up 2, over 9 up 3. Are we good with our moves from the vertex? So now, just a few minutes ago, we talked about just shifting around, and we can just shift around and then do these moves, and voila, we have the graph. So let's talk about, there are some things we couldn't have, like those negative numbers. How does that affect the domain? What would the domain of this function be?
0.
0 to infinity. What about the range? It is also 0 to infinity for this particular problem. Any extrema? We do. We have an absolute min, and that absolute min occurs at the point. 0. At the point 0, 0. You could just put the function has a minimum value of 0 because that's really what it's asking. What about increasing, decreasing? Do we have any intervals here? We only have increasing. Good. It increases from 0 to infinity. And you can already see, I failed to erase it, in behavior. Well, this one only has one end that approaches infinity, doesn't it? We only have this end over here where x approaches positive infinity. What does y do? Goes to positive infinity. Okay. Anything else? Oh, x-intercepts, y-intercepts. What are the x-intercepts?
0.
0. And what are the y-intercepts?
0.
Same thing. The x and y-intercepts on this are the point 0, 0.
Continue it to the bottom part, like flip it, make it a parabola on the bottom.
Because you're only given this part, you're actually not solving. Here we solved, and when we solve, we get the plus and minus. So if we were looking at the inverse of the parabola, you do get both parts. When you're just given this, and the square root symbol is already there, it's just the positive. Good questions. Okay. What would this one do? It would just shift up 2. And that would be the only big change, right? So when I think of this square root function, I pick the numbers I can take the square root of. The square root of 1 is 1. The square root of 4 is 2. And those are moves from my transformed point, from the new origin. Yes. Okay, domain?
2 to infinity.
0 to infinity, you can jump the boat. What's the range?
0 to 2.
That is what you meant. I know it is.
That's totally what I meant.
I know. Okay, any extrema?
Minimum.
There's a minimum at
0, 2.
at 0, 2. Increasing, decreasing. Increasing forever. But where do we start? 0 to infinity. X-intercepts? There's none. Are there? We don't have any x-intercepts. What about y-intercept?
That are not I.
At 2. Good. Are we good?
Wouldn't there be like an I x-intercept?
Okay. Could there be a difference between a 0 of the function and an x-intercept? Yes.
Yes.
The function does have zeros. Those zeros are imaginary.
Okay.
Actually, when we plug that in, when we plug in 0, we get something that will never work. We get -2 equals the square root of x. That's not possible. This one doesn't have any. Sorry.
Okay.
Jump the boat there. When we plug in 0 here, we get the square root of x equals -2. And that's, we can't do that. Okay? Not possible. All right. You try this one. Do a quick sketch and give the characteristics. what you've done? Where did you start this function? Negative 2, negative 3. Great place to start. Over 1, up 1. Over 4, up 2. And then, to the best of your ability, you drew in your little square root function. You said this function has a domain of? Good. It has a range of? Negative 3 to infinity. Is it increasing, decreasing? What's it doing? Increasing. And what over what interval is this function forever increasing?
Negative 2 to infinity.
Negative 2 to infinity. Does it have any extrema?
Yes. Negative 2.
It has the function has minimum value at the point, negative 2, negative 3, so the minimum value of the function is negative 3. We could describe one end of the end behavior, because we only have one end. All right, are we good?
What about x-intercept?
Oh, let's do it. X-intercepts, y-intercepts. Okay, so to get the y-intercept, we plug in what? 0 for x. So we get square root of, okay, so if you wanted the exact y-intercept, it would be 0, comma, radical 2 minus 3. Or negative 3.
Write it out.
Or negative 3 plus the square root of 2. There we go. There's the y-intercept. Okay, x-intercept, we plug in 0 for y. 0 equals square root of, so move the 3 over, square root of square, subtract 2. So we get the x-intercept is the 0.70. And it may have showed up pretty on your graph. I just didn't go over 9 and up 3. Any questions? Excellent. Okay, so what if we threw a negative in here? What does it do? Reflects it which way? Over the x. So 1, 2, 3, 4, 5. Here we go. So instead of going over 1, up 1, we go over 1 and down 1. Instead of going over 4, up 2, we go over 4 and down 2. No biggie. Domain?
0, 0,
0 to infinity.
0 to infinity. Range?
5 to negative infinity.
Negative infinity to 5. Yep. Okay.
Oh, because you're going. Oh, okay.
Okay. So what would the y-intercept be?
0, 5.
0, 5. We were given that. X-intercept?
5 equals the square root of x. So 25?
25, 0. Yes, 25, 0. Okay, increasing, decreasing? Forever decreasing. From where?
0,
0 to infinity. And extrema?
Absolute max.
Absolute max at the point 0, 5. Or the function has a maximum value of 5. Okay. Good? Okay. What would this do?
Yeah, stretch.
It would be a stretch. Okay, so we're going back to the negative 2, negative 3, but instead of going over 1, up 1, we go over 1, up 2. Instead of going over 4, up 2, we go over 4, up 4. Whee! Good.
Is that a, so that's a
That's
vertical
that's
stretch?
what they said first period. That's the angry eyebrow.
That's a vertical stretch, but like
It is a vertical stretch by a factor of. No, it's not the same on this one. We can't really call this one a horizontal compression. I guess you could, a horizontal compression by a factor of 4, because you'd have to have something that you could take the square root out. It would become 2. So I guess you could. It would just get uglier. All right. Let's just call it a vertical stretch. Next one. Now, we have done polynomial functions, haven't we? We weren't real specific, though, when we did one like this. We know it's going to have x-intercept where? At 3. Is it going to pass or bounce? Pass, because it's to an odd power, right? Is there an inflection point?
Yes.
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 Okay, so we know it's going to pass through there. We know that there's going to be an inflection point. We already know a lot of stuff about it. But if we were going to get more specific, we could just throw some points in here. So if this were x, what would y be? Well, y is x cubed, so what is negative 8 cubed? Negative 2 cubed is negative 8. Negative 1 cubed. Negative 1, 0, 0. What would 1 cubed be? 1, and 2 cubed? 8. So specifically, we'd be looking at this. Over 2, down 8, which takes me off my graph a little bit. Over 1, down 1. Right 1, up 1. Right 2, up 8. Off the graph once again. So it does pass through here nicely. What is this? This is my best effort at drawing this function. Okay. So there we go. This is the x cubed. And so we know the domain of this one is from negative infinity to positive infinity. The range is also from negative infinity to positive infinity. So let's go back to what we know about the inverse, because today we're adding the part of the inverse of, well, the inverse of this function. So we go in, we draw in our y equals x line. That one is a lot better. Okay, and we know it gets reflected over this, so I'm going to change to blue. All right, so 1, 1 was sitting on the line. So does it move anywhere? Okay, does this one move anywhere? No. But 2, 8 is going to switch to 8, 2. And negative 2, negative 8 is going to switch to negative 8, negative 2. Isn't that what an inverse does? It switches the x and y. So here we go. If we did the inverse of this, that's terrible. Not even close. It's still.
That would be negative x.
My lines are awful. So this is what it's going to look like. All right, so what is this function? It is the inverse of this one. What would the inverse of that look like? It's the cubed root. Good. It's the cubed root of x. Okay, so let's prove it. We're going to switch the x and y. X equals y cubed, and we're going to solve for y. Cubed root, cubed root. Do we get a plus or minus when it's odd?
No.
No, not when it's odd. So we have the whole thing here. So we know that the inverse of this cube is this cubed root. So the cubed root is the blue one, and that's what we're going to be graphing today. So today we're doing square roots and cubed roots. So this is g of x equals a cubed root of x minus 2. So what does it do with our cubed root graph? Down 2.
Down 2. I know that one.
1, 1. And then the cubed root of 8 is 2. Negative 1, negative 1. The cubed root of negative 8 is negative 2. And it looks like this. Whee!
Wait, so. Oh, so that would be the
What's the domain of this function, guys? Negative infinity, positive infinity. Range? Negative infinity to positive infinity. Extrema?
I'm just like looking at it. I'm like,
None. Good. None. All right. X-intercept?
It looks like blades on
8, 0. Good. Now we can solve it algebraically. We say 0 equals the cubed root of x minus 2. Move the 2 over. Cube both sides.
It's a heck of a lot.
Or we could just, if you had better graph paper, it would just show up. All right, y-intercept.
That would be
0, negative 2. We can read it straight off the graph. Boom. Increasing, decreasing.
Negative 2.
I thought it was a 0.
Thank you. Thank you.
from negative to positive.
Increasing from negative infinity to positive infinity. All right. Any questions? Sounds like we're good? All right. Let's change this one. This one turned out ugly. Let's put like a 3 right there.
Oh, jeez.
So, this is going to shift that pivot point.
Right.
Right 1. So, instead of going over 1, up 1, we're going to go over 1, up 3. Instead of going over 8, up 2, we're going to go over 8, up 6. So, down 3, And then 1, 2, 3, 4, 5, 6, 7, 8 would be out here, down 6.
I don't like those games.
Oops, 6. So it's going to look like this.
It looks like a roller coaster.
That's forever increasing.
There's no exciting.
It's no exciting.
I wonder if this thing's gonna drop.
All right, Demi.
No infinity costume.
Not really anything exciting about this function, is there? I mean, it is exciting looking, but. All right. Oh, I went too fast? Okay.
And I saw that one.
Oh, your talking makes me think everybody's ready. They're not ready.
I'm sorry.
How many messages left? Woo! I don't want you to look at the messages. 39. Guess what I'll be doing in my planning period? Reading emails. Yay.
But you have a longer planning period.
That's true. No, actually, I have fourth period. It didn't change.
Oh.
But that's okay. I do have the longest planning period of the day. I shouldn't.
So first and fourth period, they didn't change?
No, because they were
They are
already
later.
long.
They were translated to a
Yep.
later time during the day.
Okay. So, you don't have to take notes on these. 19 through 21, I found, and they're matching. So 19, what do you think it is? A, B, or C? B. Excellent. 20. A. And 21 would be C. Are we good with this?
Wow.
Okay. This one. Given the graph, write the equation. So, has it been reflected? No. Which function is it first? Square root.
X
Plus 2.
minus 3.
Minus 3. Any stretch? Compression?
No.
No. All right. This one. Any stretch or compression?
Yeah.
Yeah, there is. And it's also by 2, and it's what kind of root?
Cube root.
Cube root. Any shifting?
X
Minus 2.
Minus 2. Is that it? Beautiful. Okay, last one.
That's a
Minus 1 plus 1.
Okay, minus 1.
3.
3
Scale
times the
factor
square root of
3.
X.
Scale factor 3 and a plus 1. Nice job. Oh, you know what I didn't do? What would happen if I threw a negative out in front of this one?
Oh,
It would just flip this way. It would flip this way. And it
Oh,
would
that looks like the South Korean flag.
Is that Vietnamese?
Okay. All right. So for homework, we have a worksheet. It's just practice of these graphs and giving the characteristics.
Oh, we don't have IF on the